I got you with that. If the streets are parallels and they have the same slope, just find the slope of one equation.
For A, what would A be for the other side? Perpendicular. One perpendicular.
Okay. Colored pens up. So, part A. For what value of A will the two streets be parallel? Got 4 people on one side of the room, 6 people, 7 people. We'll start with Kezekiah, Ania, and then Sharik. Okay. What'd you get, Ania? I didn't say you had to. Okay. What'd you get?
Okay, for what value of A?
Part A.
Okay, well, I got A equals -1/5.
Okay, so we got 3 totally different answers. So we need someone to confirm or maybe add in another one. Catalina, Kamoy, Brian, if we still need more help, we'll go back there. So you agree with here. Who did I say was next? Kamoy, go ahead.
5.
Okay.
For A,
The correct answer is -1/5. Part B, what value of A will the streets be perpendicular? We'll start with Sebastian, Brandon, and then Jada. Sebastian. Okay? Okay. All 3 people think it's 5. That's good because it's 5.
yeah.
So could someone articulate, that's a fancy way of saying, could someone put into words what key concept will help us with part A? What key concept, Anne? Good, that's important. But why do I care about that? Yeah, okay, so I think I understand what you're saying, but you missed the connection between your 2 statements. So we're missing the key. I heard you explain it to a couple of people. Sharik, go ahead.
Okay, for what value of A are the streets parallel? In this question, I think like the connection is that for parallel, is it like that it has the same slope?
Yeah. The 2 streets will have the same slope. So the slope is missing in this equation, so what I'm asking you is, what number would have to go here for these 2 equations to be parallel lines? So I heard you actually say it to a couple of your classmates really, really articulately a few minutes ago. I don't know if you remember what you said. You said something like, if the 2 equations are parallel, then they have...
If the 2 equations are parallel, then they have the same slope.
And then you went on to explain how to find A.
Yeah, and I said, so then, well, actually, I didn't. Okay, so then for A, it would be simply the same slope. You would find the slope of that equation,
Which equation?
of the one on the bottom, x plus 5y equals 15.
Right.
You can either put it in slope-intercept form, or you can do -A over b, and you can automatically tell that it's -1/5.
That's right. So once you find the slope of this equation, that will immediately tell you the slope of that one because I'm looking to make them parallel. But then I changed the scenario in part B. I said, well, what if I wanted them to be perpendicular? So it's almost the same idea with one critical difference. What's the critical difference between the 2? Kathleen? That's right. So the perpendicular slope will be the negative or opposite reciprocal. And so you should notice, if you look here, if you look here and here, they are opposite reciprocals of each other. this is the slope of these two lines if they're parallel, but then if I want one of them to be perpendicular to the other, then I need to opposite reciprocal the slope. And so that's why we get a slope of 5. I can further prove it if I put a 5 right there and graph both of those equations using a computer or using graph paper. I would have perpendicular lines. Okay? Comments, questions, and concerns about this? Anything at all? Tristan? Okay. Well, this is a concept that you learned in chapter 5. So you need to understand that when two lines are parallel, that they have the same slope. That's it. Okay, well, Pine Street is represented by this, and Short Street is represented by this. But we have a piece missing. So what I'm asking you is find that piece. But I'm asking you to find it in a particular way. I'm saying that what would this piece be if this was parallel to this? And parallel, the idea of parallel is completely based on slope. So I'll work with you individually more, because if you're still not getting it, I mean, again, this is from 5.5, which was the middle of chapter 5. So this is something that you have to know, and you have to know extremely well. So I'll work with you individually. Any other comments or questions? Good. Today we start chapter 6. So, an overview. I wrapped up the goals into 2 statements. First major goal is to solve and graph inequalities. We're going to be doing most of that today. You hopefully noticed the title of today's lesson, which was lesson 6.1/6.2/6.3. So I am wrapping 3 lessons into 1. The second goal is to solve and graph absolute value equations. And I'll be honest with you, if you thought chapter 5 was difficult, then you're in for an interesting time in chapter 6. Because absolute value equations makes everything else we've done look like a joke. But here's the good news. Most of my students, somewhere around this time, somewhere around holiday time or a little bit afterwards, a lot of my students start to understand things that they didn't understand before. That's just the nature of you developing as a young person. Your brain starts to work at a higher level, and you may not even know what's going on, why it is, but you just are going to start understanding things more. Part of it has to do with the fact that I've been pushing you for a long time now. But having said that, there is a decent chance you're going to struggle during this chapter. So that's the overview. 6.1, 6.2, 6.3 is all solving inequalities, so we're going to start with that. We've been studying equations and different forms of them for a long time now. And our goal has always been to find a solution. Or in the case of chapters 4 and 5, with linear equations with 2 variables, like y equals 3x plus 5, we were trying to represent solutions using a line. But those equations work for certain types of scenarios. There are certain scenarios that an equation will not work. And for them, we use an inequality. In this case, in prefix means not equal. You had a long introduction to inequalities last year in pre-algebra, so I am going to proceed as if you have a very good understanding of what these look like, what the symbols mean, and how it works. And then I'm just going to take it to the next level. So, we're going to be graphing today But it's going to look totally different than the graphs we've done all year. We're not going to be graphing on a coordinate grid. We're going to be graphing on a number line. But we're still using graph paper because the graph paper is going to make it very easy to draw a number line. And the reason we graph on a number line is inequalities have many solutions. And so instead of listing all the solutions, we don't list them because we'd be writing forever. Instead of listing them, we represent all of them using a picture, which is called the graph. So that's one thing we're going to do today. The other, and you were also introduced to that last year, so you should have a good idea of how it's graphed. I'm not going to talk about the details of it. I'm going to expect that you know it. You'll see it again, and hopefully the memories will come back quickly. Solving inequalities. You solve inequalities the exact same way you solve equations. All of the skills that you perfected for the first 3 chapters in my class are all going to be used today with one extra detail. Here is the extra detail. During a transformation, if you multiply or divide by a negative number at any point, you flip the inequality symbol. And there is a very good reason why you have to do this. I'm not going to explain during today's lesson. But some of you, as you see what happens throughout today's lesson with the different questions we do, you should start to notice or start to think about why. Why do we have to flip the symbol? Why can't we just leave it? There is a very, very good, simple reason why. Hopefully you noticed that I put this detail in a big banner with color and big font, and so it's pretty important. I also put it like this because I wanted it to stick in your mind as a banner that's just there in your brain, constantly in the background as you're working through the material we're studying. What do I mean by that? I mean it's a question that you're going to constantly have to ask yourself over and over again. Did I multiply or divide by a negative number? Did I multiply or divide by a negative number? Oh, I did? I have to flip the symbol. Oh, I didn't at any point? Then I leave the symbol alone. If right now you have no idea what I'm talking about, don't worry. In a couple of minutes, it should start to become more clear. Does anyone have any questions so far about this new detail that we have to pay attention to with inequalities? Anything, any terminology? Okay, if you're missing anything from this part of the notes, then you just ask me. I have a printed copy. Excuse me, I can give it to you during classwork time. So we're going to jump right in and solve and graph some inequalities. Today's lesson, we are starting simple and then working towards the more complex for one reason and one reason only. I want to make sure you understand this new rule. So rather than jumping into complicated inequalities, I want you to see a couple of simple ones so that we digest this new rule. So, I would like all of us to solve the inequality negative 6x is greater than or equal to negative 24. So, just to make sure we're seeing the same thing, I'm going to write something over here. I don't want you to write it. Negative 6x is equal to negative 24. This is an equation. That's an inequality. They are solved the same way. So let's focus on what I wrote in orange for a moment. You don't have to write this. You just need to look. How would I solve that equation? Anita? Yeah, what would be the first step in solving that? Well, that's sort of what you end up doing, but that's not the way we were taught to explain it. And it's a little bit, it's important, the detail that I'm going to focus on. Kristen? No, Ania said the right thing, but she's missing a detail. No, we're not dividing the -6 by the -24. No. Sebastian? Yeah, you guys are missing the 5 words that we talked about a long time ago. Divide both sides by -6. So this cancels out, and we get x is equal to, and we get a 4. So we already know that when we solve this, there's going to be an x and there's going to be a 4. The question becomes, what symbol will be in between? So, this is not what we're doing, but I wanted you to see that it's the same process. So now you guys can write along with me. If you need to draw your t, go ahead and draw a t, but at this point, I don't know if you really need it. And we're going to do the same transformation. This is called a transformation, because what we're trying to do is transform the equation or inequality. So it's called a transformation. This cancels out, and we have our x. But that banner should be in your mind, and you should be asking yourself, did I multiply or divide by a negative number during this transformation? During this step, did I multiply or divide by a negative number? So it's a yes or no question. Hezekiah? Yes, we did. Which means that we have to flip this symbol. And when I say flip, I mean it's pointing to the right, now it needs to point to the left. And now we do -24 divided by -6, and now we get our solution set of x is less than or equal to 4. Does anyone have any questions so far? Come on. Nope, because our transformation would be dividing both sides by 6. So it depends on what number you're using here. If this is a negative number, then you flip the symbol, okay? So now, we need to graph. So now you need a number line. You should have a ruler, as I already explained, you needed a ruler. You don't have to draw the vertical lines because your graph paper does that for you. But now we need to graph, and I want to make it simple for you guys. Okay, so the simplest thing to do is, I'm sorry, let me back up, I got distracted. We have to label the number line. So a lot of people just put a 0 and then they start filling in numbers, but you actually don't have to fill in a 0. You don't have to fill in anything in particular. All you have to do is make sure that your interval is always the same. The easiest thing to do is whatever this number is, you put that somewhere near the middle. And then just label, that's a 5, that's a 6, that's a 7, that's an 8, that's a 3, that's a 2, and that's plenty of labeling. You don't need to label any more than 4. Because I know I can count, that's 9, 10, 11, 12, 13, 14, so I can see all of that. So go ahead and get your number line set up. So now, the way we didn't graph yet, all we did was label the number line. Now we need to graph, and we're going to put a circle on top of the 4. But there's 2 different types of circles. Let's see who remembers from last year. What circle are we going to use for this? Aliana? Good. Very good. So there's an empty circle and there's a filled-in circle. Which one are we going to use for this? Alyssa? You're right, but what detail tells you that it has to be filled in, Alyssa? Yeah. This line, if there's a bar underneath, then you fill in the circle. If there's no bar, then you leave the circle empty. Now we need to shade half the line. We need to shade either to the left or to the right. Which way do you think we need to shade? How about we do it this way? I want you to actually pick one of your arms, and if you think we're going to go this way, put your arm that way. If you think we're going to shade this way, put your arm that way. Let's see. Good. So we have some nonconformists. That good? Oh, no, she's a conformist. Okay. So put your arms down, and that is correct. We are going to shade to the left. So we are going to shade everything over here. And then we also put an arrow on the end. And that arrow, very important, that tells anyone looking at your graph that the graph actually goes on and on forever. And you have to do that because you are trying to represent all the possible solutions. Could someone give me a solution to this that's really an extreme number? Like, someone come up with like an extreme example. Kayla? Negative 121. Good, that's perfect. So I went by ones. So that's 2, that's 1, 0, negative 1, negative 2, negative 3, negative 4, negative 5. So I am able to fit up to negative 5. But negative 121 is one of the solutions to this. So how would I represent negative 121? I would need a piece of paper that went all the way across the hall, through the computer lab, through the office, all the way to the other side, and probably beyond. I mean, think about this amount of space from here to here, and I would have to do that another 120 times. So we can't do that. I don't have paper that big, nor would I want to. So instead, we draw the arrow. The arrow is what says, okay, now it keeps going on forever. Okay? Could someone explain what this side of the graph is representing? What is this side representing? Sebastian? That was very well said. This is all the numbers that will not solve the inequality. If I put in 8 right here, 8 is not less than or equal to 4. So that doesn't solve the inequality. And then again, there's an arrow here, so that goes on forever and ever to the right. So the number 1,000 is not a solution. Okay? Does anyone have any questions on how this works? Give me a thumbs up if the details about inequalities are starting to come back to you. Not necessarily all of them, but maybe some of them are coming. Good. So some of them, good. Put your thumbs down. Well, again, we're going to continue, and hopefully it will continue to come back to you. So let's look at part B. And I want to solve the inequality and then graph it. And again, I'm intentionally starting with simple ones. So everyone in the room should be able to solve this almost instantly. But just to make sure we're all on the same page, what do I have to do to solve this? Hezekiah? That's correct, thank you, but how? Go ahead. You said that perfectly. Subtract 10 from both sides. But now I have that banner in my head. That banner that said, if I, during a transformation, that's this, if I multiply or divide by a negative number, I have to flip the symbol. So what do you think? Does the banner apply right now? Yeah. Kayla? No. Well, a whole bunch of people chimed in yes. You think no? Why does it not apply? That's right. We did not multiply or divide by a negative number. We subtracted. So we do not flip the symbol. We leave the symbol the same. And then, of course, negative 23 minus 10 is negative 33. So we've done one example where we do flip the symbol, and we've done an example where we don't flip the symbol. But the banner, that message, has to be in your brain. Does anyone have any questions about that? Any questions about that? Brandon and then Sharik? You don't need to, because you don't have to put a 0 anywhere on it. Yeah, you don't have to break it. That's a good question, but you don't have to break it. So we have to graph a negative 33. What he's saying is, well, I can't fit a 0 and a negative 33, so how do I do that? You don't have to put a 0. Put the negative 33 wherever you want, somewhere near the middle. Here, let's put it right there. That's negative 33. That's negative 32. That's negative 31. I'm skipping every other one because I don't have enough space to write it. If I tried to write negative 32, it's going to look like a big mess. So instead, I skip over it. And so then that's negative 30, and that's negative 29. And that's negative 34, and that's negative 35. And so now I've labeled 4 of them, and that's more than enough to make it clear. And now I need to put a circle on the negative 33. Which type of circle am I going to use this time? Eliana? Very good. The empty or open circle. Because negative 33 is the starting point, but it's actually not a solution. If I put a negative 33 right here, that will make a false statement. Negative 33 is not less than negative 33. So negative 33 is not a solution, and that's why we leave the circle open. It's just our starting point. Now I need everyone to put their arm out, one of their arms out. You need to put your arm to the left or to the right. Which way are we going to shade this time? So everyone thinks we're going to shade to this side. And that is correct. Does anyone remember a trick that Ms. Cooper taught you that makes it easy to remember which way to shade? Shelby? No, that says x is less than negative 33. You're talking about this symbol here? Okay, go on. So that's x is less than negative 33. That's right. Look at this symbol and look at the end of the arrow. It's the same. But there was one detail that you had to pay attention to for that to work. It only works if one thing is true. That's right. Wow, very good memory. Yeah, this only works if the x is on the left. If you get a solution that looks like this, and I'm going to make up a totally different one. Excuse me. If you get x is less than 30, you would think that you graph to the right, but you actually don't. The arrow is pointing to the right, but that little trick only works if the x is on the left. But here's the good news. You're always going to write the variable on the left. The symmetric property also works for inequalities. But there's one thing you have to make sure you understand. When you flip everything, you have to flip the symbol also. So if I ever get a solution like this, you flip the whole thing around. Not just switch the x and the 30, you have to flip it. So this would become x is less than 30. And then you can use Ms. Cooper's rule of looking at the arrow, and that's the direction we're going to shade. Okay? Brandon, go ahead. Flip it like a pancake, that's right. And so that, it was for something else, but I think it does apply. Flip it like a pancake, I think, is used for a few different things. But it actually does apply because when you flip a pancake, whatever imperfection was on this side, when you flip the pancake, is going to end up on the other side. So you're not just switching it, you're actually flipping it. And that's what you're doing here. So I think the idea does apply. Okay? Any other comments or questions? Good, so that was the introduction. Now let's go to the real work. So now we have higher complexity, same idea. But the good news, the very good news, is you already know how to do it. There's nothing new to learn. except for that one rule. So if we multiply or divide by a negative number during a transformation, then we flip the symbol. Other than that, we do everything we already know how to do. So, just to make sure we're all on the same page, I do feel strongly that you should be able to solve this pretty quickly. But let's make sure we're all on the same page. What would be the first step? Not nearly as much confidence as I thought there would be, but go ahead, Anissa, start us out.
Subtract 6x.
Yeah, you actually could subtract 7, you could add 9, you could subtract 7x. Any one of those would still get you the right answer, but I taught you to subtract 6x from both sides. This will disappear, but now I have that banner. Did I multiply or divide by a negative number? No. So I do not touch the symbol. It's going to stay the same for now. So now I have 7 is greater than or equal to x minus 9. What's the next step in solving? Kayla? Very good. You said that beautifully. Add 9 to each side. This disappears. I now have my x by itself. Did I multiply or divide by a negative number? No. So the symbol stays the same. And now I have my starting value. But, as Catalina pointed out, we want the x on the left. And as Brandon pointed out, we want to use a spatula to flip the entire thing. So our real solution is x is less than or equal to 16. And that's really what we were looking for. Does anyone have any questions on how we did that? Jada? No, you're thinking of something different. The symmetric property says that I actually can flip it. That wasn't called for. I wasn't trying to one up her or anything. That's true, that's true. I do appreciate, but were you thinking of, there's a few students, I don't know how many of them are in this class, but there's a few students who solve equations a little bit differently than the way I taught. Some of you guys move things from one side to the other. Does anyone do that? So if you don't know what I mean, then you don't do it. But if you move any of these terms from one side to the other, instead of subtracting 6x from both sides, you could just say, I want to move that over there. But if you move it across the symbol, then you have to flip its sign. So I don't know if that's what Jada was talking about. Was that what you were talking about? Okay. Oh, you're saying that if I flip it around, it's going to turn into a 61, like a mirror? That's a good point. Now I understand. I did not understand it at first. Now I understand.
It's flipping it.
That is a good point. You're right. So it would say x is less than or equal to 61. You're right. Very good. So, but this is how it actually works. So I apologize for misunderstanding you. So, any other comments or questions before we graph? Okay, so now we need to graph a 16, and now graphing is going to go very quickly. I'm not going to really spend any time on it. I'm just going to do it. You're going to do it along with me. 16 will go somewhere in the middle, 17, 18, 15, 14, 13, 12. We already know it's a filled in dot, filled in circle, and we already know which way to graph because we're using that little trick. Does anyone have any questions on how we did this higher level inequality? Yes and then yes.
Oh, wait a minute, never mind.
Okay. Yes.
So if you didn't flip it with the arrows, so we're going the same way?
Yep. This is the graph for this and this because these two are equivalent. This is just a better way of writing it. Okay, Catalina?
I just thought of this question. What do you do if after you solve an inequality, like to get x is that? What do you do if the x is negative?
It's a very good question. We'll find out. Very good question. All right. So, part B. And this is the type of question, and I know you're copying it now, and hopefully you're starting to see some of the details of it, but this is the type of question that will separate my moderately successful students from my highly successful students. Because this is a type of question or inequality that truly shows that you understand the rule about flipping the symbol. So, let's go ahead and solve this, and then we'll talk about what's happening as we go along. What's the first step in solving this one? Oh, we got a lot of confident people. Tristan? Very good. We distribute. So we're going to multiply, we're going to multiply and multiply. So, the left side I didn't touch, that's negative 12x plus 8. The right side is going to be negative 27x plus 3. The question is what symbol should go in between? What symbol should go in between, Ryan?
I think it's the same one because you didn't divide or multiply by both sides with a negative number.
And that's right. And so he's already understood the rule instinctively. This, even though I am multiplying by a negative number, that's not doing a transformation. A transformation is when you do something to both sides of the inequality. This is called simplifying. At some point during chapter 3, I talked about the idea of simplify, then solve. I actually think Sharik was the one I would call on all the time, and he would always go, simplify, then solve. Simplify, then solve. So, that simplify, we simplify and then solve. Transformations are the things we do while solving. This was just simplifying. And so Brian's interpretation was perfect. We are not going to touch the symbol. We only do something if we at some point multiply or divide both sides by a negative number. Very good. So now we've simplified the right, we simplified the left, now we're ready to solve. So here's the point where I would say draw your T. You don't have to if you don't need to anymore. But what is the next step in the solving process? We've got a lot of confident people. Anit? You can do that. You can add 12x to both sides, and you will get the correct answer. But that's not what I taught you to do. You can do it, and it will work. But what did I teach you to do in this case? I know Anissa knows because she did it in the last one. Go ahead.
You add 27.
Yeah, why is that a better choice than doing this one?
Because that one's less than.
Yeah, this is the smaller coefficient, and what will happen is we will end up with a positive number instead of a negative one. So, Ania, please understand that you can do what you said and you will still get the correct answer. It will just be a tiny bit harder than doing it this way. Okay? So this will cancel, and now we add down, we get 15x plus 8. Now, did we multiply or divide by a negative number?
No.
No. So the symbol is still going to be the same, and then we have a 3. How many steps do you think we have left? Kamoy?
1.
Think we have 1? Well, my high-level students could probably do it in 1 step, but it's probably not the easiest one to do. So what is the next step in solving? What's the next step? Sharif?
Subtract 8 to both sides.
Subtract 8 from both sides. Did I multiply or divide by a negative number?
No.
No. So the symbol's going to stay the same still. I'm left with 15x is less than negative 5. What is the final step? Final step. Alicia? Very good. And so I'm dividing by 15. Did I multiply or divide by a negative number? No, I'm dividing by a positive number. And so nothing happens to the symbol. And I am left with x is less than negative 1/3. Does anyone have any questions about how we arrived at that solution? Now, I actually picked this question in particular because of having a fraction as an answer. And I know I accidentally erased part of it, but that's not a big deal. So we know that the solution is negative 1/3. So what could we label? How could we do our number line?
Label it negative 1/3 and then go by thirds.
Yeah. This is where you have to be careful. We'll put negative 1/3. Here's something that you cannot do. You cannot now say that that's 0 and that's negative 1. You cannot do that because that would mean this interval is 1/3 distant and that one is 2/3 distant. Because it's 1/3 from negative 1/3 to 0, it's 2/3 going the other way. You can't do that. The interval has to be the same. So Sharik is right, you have to go by thirds. Now, it does so happen that 1/3 going this way is 0, but 1/3 going that way is negative 2/3. And then going another third this way would be positive 1/3. And so now I have an appropriately labeled number line. Again, the point is the interval has to be the same throughout the entire number line. Now we're ready to graph. It does not have the bar underneath, so we have an open circle, and the arrow is pointing to the left, so we're going to shade to the left and put an arrow on the end. Does anyone have any questions on how we did this? Kezgai? Correct. Very good. Any questions on either of these? Okay, checkpoint number 1. You do not have to copy the original, but you have to solve both of them and graph. So you've got 2, you've got 3 minutes. Now we'll make it 4 minutes. If you have any concerns or confusion, raise your hand and I will come help you. Thank you for You don't have to. You can keep finishing. It's okay. Another 30 seconds, not a big deal. Okay. So I'm just going to talk about the solutions initially. So what do we get for part A? 1, 2, 3, 4, 5. Confident people to semi-confident people. Start with Kamoy, Ania, and then Jada. Kamoy, what'd you get? Okay, what'd you get, Ania? Okay, so we have a disagreement. What do you think, Jada? So it comes out to x is greater than negative 5.2. And what about part B? What did you get? Start with Catalina, Hezekiah, Brian, and then Alicia. What'd you get, Catalina? Okay. So you got the same thing. Okay. Brian? Okay, that's the same value, just written differently. Okay. Okay, so you agree with the way he did it. And that's all correct. X is greater than or equal to negative 1 and 1/2. I actually do not have the graphs up here. At this point, you are going to graph most of the things that you do from now on. But there's some that I just may not spend the time showing here. It's just in inches of time, that's all. Okay? It's not that it's not important. I just think at this point you should have a very good idea of how to graph. Jada, go ahead. Negative 1.5? That's the same thing. Comments or questions on either of these? Kamoy? Okay, did you get B? Which question do you think is harder? Which one looks hard? B looks much harder, right? So you did the really hard one, And the really hard one used the skills that you needed for the easy one. So something went terribly wrong with the one step that part A required. But why would you do that? Okay, but we only need to move the x if there's an x on both sides. Is there an x on both sides? So you don't need to move the x. You overthought it. You went too far. Could someone sum up how many steps does part A take? How many steps? Alyssa? Yeah, that was a one-step equation. Look at that, the top row of my board back there. We're talking that first poster, one-step equations. Now it's an inequality, and that's a little bit different, but solving is the same process. So you way overthought it. You used the skill from way, the multi-step one, for something that just required one step. Okay? Do you see it now, or is it still not clear? Okay. Any other comments or questions? Good. Give me a thumbs up if you got both of them right. Okay, put your thumbs down. Give me a thumbs up if you got part B correct. Put your thumbs down. Very good. Now we're going to take the idea and apply it to a real-world scenario. So, example 3, everyone needs to write example 3, part A. You do not need to copy the question, but you need to, of course, read the question. Now, I always like to use prior knowledge. I like to use what we already know to help us with what we're learning now. So let's pretend for a moment that it doesn't say write an inequality. Let's pretend that it says write an equation. And let's pretend for a moment that it says that I want to earn exactly $650. If I want to earn exactly $650, what equation could I write to figure that out? I know some of you could do it mentally or using just a calculator, but I want an equation. Sebastian? Very good. Now we're given the letter H, so we're going to use the letter H, but that's the same thing. So 8.75 times the number of hours will give me $650. But now I'm not saying that I want to earn exactly $650. I'm saying I want to earn at least $650. So now we're not using an equation. This is only solvable using an inequality. So we don't use this. We need a different symbol. So now I want you to think about it, and I want to see if you can figure out what symbol we need to use. What symbol would we need to use? I have a lot of people who think they know. What do you think, Brandon? Greater than or equal to? Give me a thumbs up if you agree with him. Greater than or equal to. Okay, Tayanara, what did you think it was? You're not sure. Then that's totally fine. So, what word or phrase helps us? What word in the question or phrase in the question helps us figure it out? And that's the phrase, at least. And now, I want to help Dayanara and anyone else who struggles, and I'll be honest with you, I have a very difficult time personally with this. So I figured out a system that works for me. I'm going to share it with you. I think of the words minimum and maximum. And then I try to pick something out and figure out if it's a minimum or maximum. So here's my question. It says I'm going to save at least $650. Is the $650 the minimum amount I should earn or the maximum amount? Is it the minimum or maximum? Alyssa? It's the minimum. That's the lowest amount I want to earn, right? So I want to earn $650 or anything beyond that. And so Brandon was right. we want greater than or equal to, because the minimum always gets the point of the arrow. The minimum always gets the point. And so if you can think of things in terms of minimum and maximum, that might help you figure out what symbol to use. Now, the reason that it's or equal to, why is it or equal to? Why is it not just the greater than? Kayla? It doesn't have to be exactly 50? That's right. But the more than is this part. What I'm saying is, why is there that part? Catalina?
Because it can be exact.
That's it. So you were right, Kayla. We can get more than 650, but we can also get exactly 650. And that's what determines whether we should put the or equal to part or not. Okay? So now we need to solve this to find out how many hours. So go ahead, you take 30 seconds and solve it. You don't really need me to solve it with you. How many hours is it going to take to make $650 or more? How many hours? Got 3 people, 4 people were able to do it? Okay, Kamoy, how much did you get?
$75.
What do you think, Sharik?
I agree with that. 75 full hours.
Yeah, I like the way you threw in the word 75 full hours. It is 75 hours, but Sharik, what made you add the word full?
Because it says, why in inequalities show how many full hours you need to work to save at least 650?
Yeah, it says it right in the original question. But what was the exact answer that came out? Because he probably wouldn't have said full if his answer came out exactly 75. Brian, what does it come out to?
74.28571.
Yeah, 74.2, approximately 29. But when you get your first job, which is actually only a couple of years from now for most of you, you don't work partial hours. I mean, you might work a half hour, but they pay you in terms of full hours. Okay, so you would need to work 75 full hours to make the 650 or more. Okay? If your employer allowed you to work fractional little bits of hours and somehow would allow you to work 29% of an hour, then you would earn exactly $650 at that moment. But most employers don't allow that, so you would have to get 75 hours. Okay? Good. Comments, questions on how we did that? Tristan?
At least eta is the opposite of the total.
I like that.
Yeah. Because the minimum gets the point, the maximum gets eaten up by the alligator. That's right. Okay? Sebastian? Why don't you tell me? Why not? You can, absolutely you can. I was waiting for someone to ask that.
What happens?
He's going to tell us in a moment. Now, I have another question that we're going to look at, but we're not going to do. I just wanted to show you other types of, so don't write this down, I just want you to read it to yourself. You don't even have to write part B, because we're not going to do it. But I want you to see other types of questions that you're going to be asked to write and then solve. We learned how to write things like this. Not quite this complex, but we learned how to write equations and inequalities from sentences a long time ago. So now it's coming back. Does anyone remember the technique that I taught to help you be very successful with stuff like this? There was something specific I told you to do. Alyssa? Yeah. Now you don't have to, At this point, now that you're used to everything in my class, you might be fine just reading the product of 3 and the difference of 2 and 4x. You might be able to do it that way. If you can, that's fine. You don't have to do it my way. But if you do have a difficult time interpreting this, starting at the end and reading that way does help. Because if you just kind of chunk it into pieces, okay, I have a 7x. Okay, I have a 5x and a 7x. What am I going to do with them? Oh, the sum of 5x and 7x. So I know how to write that chunk. Now keep going backwards. Equal to. Oh, less than or equal to. Oh, so there's another chunk that goes up to here. Is less than or equal to. So there's another chunk. So if you break it into chunks going backwards, it can help you interpret it. But if you don't need to, you don't have to. Okay? So this is another style you're going to see. But I thought it would be better to have you work on a question individually to give you a chance to demonstrate that you're understanding. So, checkpoint number 2. You, of course, do not have to copy the question, but the question is broken into 2 questions, really. So first, part A, write the inequality, and then part B, tell me what possible numbers will work. So go ahead. You've got 3 minutes to figure this out. Correct. Keep going and see what you come up with. It'll start to become clear to you as you work through it. All right, colored pens, and let's see how we're doing. What's the inequality? 1, 2, 3, 4, 5 confident people. We'll start with Jada, Ania, Sharik, Alicia, Brian. Jada, what'd you get? Just A, yeah, we're just working on A. Okay. Okay.
Okay, C is greater than 30.
Okay. So a slight disagreement. No, see, I don't think you did. So why don't you say what you put? Just trust me. I don't care. Say what you said. Say it louder so everyone can hear. Okay, so that is different. Good, Brian?
C is greater than 30.
So for part A, what I was looking for was this. 2C is greater than 60. And the letter doesn't really matter. So it doesn't matter if it's an X or C. It doesn't really matter. But C for cards, so 2C is greater than 60. Don't worry, we're going to talk about it in a moment. Part B, what's the possible numbers of cards that you need to have a profit? Brandon, and then come on. Part B. Part B. Tell me what you got. Okay, good boy. Okay, Shelby. Okay, so what I was looking for here is C is greater than 30. Now, Shelby, sounds like what you put would also make sense as well. So, did you put a solid dot on the 31 or an open dot on the 31? So then we're a little bit off, because here's what you got to understand. Let's forget about part B. It cannot be or equal to. Can someone explain why it cannot be or equal to? And? That's right. If you put or equal to, you wouldn't be, one of the solutions wouldn't make you profit. And so that would be a false situation, right? Because if I sell exactly 30, I make my money back, but I don't make a profit. And so it's very specifically worded, for the profit to be positive. I didn't say so that you break even or make a profit. I said so that you made a profit. So in this case, it cannot be or equal to, because equal to means you don't make a profit. Now, interpreting the two questions, I'll grant you that it was a little bit hard to understand what I was looking for in part A and what I was looking for in part B. And all of you who put this answer for part A, I don't blame you. I had tons of students every year tell me something similar. So that's fine. Don't beat yourself up. You clearly understand what you're doing. It was just a matter of interpreting and trying to figure out what was expected in each question. Okay? Ania. Okay. Good. How did what? How did it happen? I don't know. I'm not a guest in your brain. I can't tell what went through your mind when you did that, but I can take a look at what you did and we can try and figure it out. Shelby, and then Moy, and then I got to move on. Well, you put the open circle, and what that means is you're not including 31, but 31 is one of the solutions. So you got it partially correct, but you forgot one of the solutions, 31. So you had the right idea, you just missed that one detail. Come on. Yes, and that's what Shelby was trying to say. So I have had students in the past, and this morning I had one student who said, would this be okay? And absolutely, that is actually, these two expressions are really equal to each other. The only difference would be is if you were talking about decimals, because this includes the decimals from 30.0001 up to 31. So this technically does include a tiny set of solutions, but in this case we're not talking about decimal numbers because you can't sell part of a card. So in this case, either one of these would work. Okay? I do need to move on. I want to make sure you guys have enough time. So draw a line across your paper. Your classwork. is on 2 separate pages. We're going to start with the more challenging first and then work our way backwards. On page 62, you're going to do 30, 29, 23, 9, and 6. That's 5 questions. And then on the page before, a couple pages before, you're going to do 4 questions. So you got about 12, 13 minutes. So it's the same here, except we have to figure out which one. You can tell the difference because if this is a true statement, then that's all real numbers. If that's a false statement, that's no solution. So it's definitely challenging, but all the information you use is right. Okay. Pick up your colored pens, and here are the solutions. Number 30. The publisher wrote it in a strange way. That would actually, for me, be 80W is greater than 420. And I'm pretty sure that's what most of you put. And then we're looking for 6 wall hangings or more. If you put W is greater than 6, that's the same thing. That's what I was looking for. Number 29, you had to write it out, solve it, and graph it. Number 23 was a special case that we did not talk about in class and is definitely not easy, but that is a case of all real numbers. Number 9 comes out to Z is less than or equal to 7/8, and number 6 comes out to C is greater than 12. On the next, oh, and there are the graphs, sorry. On the next page, number 20, 7 flats or less. And of course, if you wrote X is less than or equal to 7, that's what I'm looking for. Number 17. Page up so you can see the rest. And the last 2. Kamoy, then Brian, then Kayla. I'll show you in a moment. That's the same thing.
For number 20, could you also put 0 as x is greater than 0 to less than 7? You can't provide negative flats.
That's a very good point. You can't have negative flats. You're absolutely correct. Kayla, and then Catalina, and then Brandon. Okay?
2 things. One, for you know how the answer was all real numbers for 23? Well, it's for the directions, it says solve the inequality if possible. Would that mean it's not?
That's a good point. I would say that it's not possible to find a particular solution or set of solutions because it comes out to all numbers. Okay?
Never answer my negative x question.
I was hoping you were going to figure it out as we went along. Oh. Okay, well, we'll see, because it's going to come up during the homework. We'll see if you figure it out. Brandon, and then I got to move on.
That's the same thing I said.
Yeah, you make a very, very good point. Brian's point and Brandon's point is you can't buy negative flats. So technically, you can't. -1 is not really a solution. Neither is -10 and -100. So they make a very good point. but we didn't learn compound inequalities yet. We're going to learn that next time. So I didn't really expect you to know how to do that. So you guys went beyond my expectations. So unfortunately, I am out of time. So let me get you your homework. And then I will teach the all real numbers and the no solution next time. So you can give yourself half if you didn't put that exact answer. Your homework is on 3 different pages, and it's a little confusing looking, but it's just 23 questions. Page 367, you're doing 4 questions. 374 is the next section. You're doing 20 to 32 even and number 42. And then 380, you're doing numbers 14 through 34 even. Read the next section. For some of you, you will be able to do the next section without my help. You'll be able to figure it out. And then you're going to have a quiz after Thanksgiving on 6.1 to 6.4. I'm just giving you a heads up now.